Hello, in this video we are going to be talking about section 6.1, which is about rational functions, but more importantly we're actually going to be talking about simplifying rational expressions. Now when you think about a rational expression, this is basically any expression that can be represented as a fraction. So some even simpler rational expressions that you've seen before in your very beginning math classes are things like 1 over 2, because that is something that can be written as a fraction format. But the kind of rational expressions that we are going to be talking about in this section are the ones you see listed down here below. We're going to talk about how to simplify these 5 rational expressions. And to set the stage for how we're going to do this, I want to take a look at this first very simple one. And I know that we've talked about and even simplified expressions like this already in the class, and the easier way that we talked about doing this was just saying, okay, well 10 goes into 30 3 times, and then there's 2 x's on top and 1 x on the bottom, so we cross out an x from the top and bottom, leave 1 on the top, etc. But I want to talk about the longer way of doing this, and that's by factoring both the numerator and the denominator. So if I were to do that, this would look like, on the top we'd look like 2 times 5 times 2 x's and 3 y's. And then in the denominator, 30 can be broken down into 2 times 3 times 5. And then we have 1x. Then we have 4 y's. This is the very first way most of you have probably seen how to simplify these type of rational expressions. It's not the fastest way, but it does show exactly what's going on, because then what we do is we go ahead and we simplify. We divide out the common factors. So since we have a 2 and 2 on the bottom, we divide those out and they just become 1. We can divide out the 5's. We can divide out 1x from the top and bottom, and then 3 y's. So what you're left with is, on the top all we have is x, and on the bottom we have a 3 and a y. So this simplifies down to 3y. That's kind of the way that we would factor this sort of rational expression. Now, again, as I mentioned earlier, the way you would probably do this if you saw this on a test is you do something like, okay, well 10 goes into 10 once, 10 goes into 33 times, so that leaves 3 on the bottom, which we had, and then there's 2 x's here and 1 down here, so there must be 1 x left on the top, and there's 3 y's on the top and 4 y's on the bottom. That leaves 1 y on the top, and we'd come to this answer. It's a lot faster. The reason why I did this example first, though, is because when we are factoring rational expressions, our first step should always be to factor. So let's just make a little note here. Note: always factor first. And actually I'm going to type this in. I think that'll look better here. Let me type it in. Let's make a little note here. Note: factor first. Well, let's say always factor first. How about that? Always factor first. And we can underline that. that's what we want to do for each one of these problems. So luckily we just spent chapter 5 talking about how to factor trinomials, which is what we have in this first example, more complicated example. So let's go ahead and factor the numerator and the denominator. The numerator is going to factor into two binomials. We've talked about how to do this, so we're not going to spend a lot of time going over that. And the bottom will also factor into two binomials. And the top, we know that the first two spots must multiply to give me x squared, so that's got to be x and x. And the second two spots have to multiply to give me positive 20, and we have a 9x here, so to get 20 it's got to be 5 and 4. And it turns out that a plus 5 and a plus 4 does add up to give me 9, so this has got to be plus 5 and plus 4. And then on the bottom again we should have x times x. And to get negative 15 we're going to need a 5 and a 3, and one of them is going to have to be negative, and since we want positive 2, what I'm going to want is positive 5 and negative 3. And I'll just do this on this example. We're not going to do a whole lot of this. As we talked about earlier, this is we want those signs because our inner product gives us 5x and our outer product gives us negative 3x, and altogether those add up to 2x, which is what we had right here. So let me go ahead and erase that, and we've now factored the top and bottom, so we can go ahead and simplify. So when we simplify, we're going to cancel out our common factors. We have x plus 5 on the top and x plus 5 on the bottom, and all we're left with here is x plus 4 on the top and x minus 3 in the denominator. Now then, the question I always ask students is, at this point, can I go ahead and cancel anything out? Can I cancel out these x's, for instance? And I always have students that say yes, but we cannot do that. We cannot cancel out these x's because they have a 4 and a negative 3 attached to them, so these are not common factors that we can divide away. So this is our final answer, and why don't we just make a little note here. This is not equal to, a little equal sign with a slash through it, this is not equal to 4 over negative 3. We cannot say that is true, so no.